Afternoon. It's really an honor to share this research with all of you. Let me start saying that I believe we can all agree that we acknowledge PPPD to be a functional disorder. What does this mean? That there is no specific structural or subcortical abnormality, but that the issue lies in a higher order, a higher hierarchy, cortical dysfunction. Now, the question we all ask is which dysfunction, where it is, what are the mechanisms? Well, our group has posted from a couple of years now that the issue lies in a mismatch between predictions and reafference not only of the body perception, but of the body in relation to space, a little broader than the limits of our body. So if we were going to speak about the body, the position of the body in space, we're talking about spatial cognition, in particular of spatial navigation. So we believe that a core feature in PPPD is that this function is it's broken, and that an impairment in spatial navigation is a core feature of functional dizziness. To test this, we have now have new data of a new group of PPPD patients where we have tested them through a Morris-Watermaze spatial navigation test. For those who do not know this test, we put it started being for rodents. We can do it for humans in a virtual setting, but the subject looks a hidden platform in a round pool surrounded by visual cues, and after finding it, you have to remember what it is. And in subsequent trials, it constructs a more direct route to finding it. So that makes spatial navigation learning. We have done this in a 2D non-immersive setting in front of a computer monitor, but now we have added virtual reality, which and also we have not only analyzed the behavior of finding the target, but also we have now looked into what has happening with the eyes, where is the gaze going in terms of exploration of this virtual setting, and what happens with the head movements in terms also of exploration of the head. We thought it will involve vestibular cues to the experimental setting. We tested this comparing the PPPD group with the vestibular non-PPPD group, which also has the same number of other diagnoses, but non-PPPD, and also a group of healthy volunteers. In a rather post-hoc data treatment, we added a vestibular migraine group, selecting the patients with that diagnosis for further comparison. So, this is how a spatial navigation Morris-Watermaze looked like in a single example subject. Each line is the trajectory looking for the hidden target in a quite good fashion. And that's a healthy volunteer. And this is a PPPD patient. He messes around and goes around in circles, not finding it. Even after finding it, it cannot remember and cannot navigate properly. If we look this not in a single subject, but in all subjects put it together, we can construct these heat maps that in the right, in the healthy volunteers, focus near the target, and in the PPPD it's actually all the way around. When we put these graphs for the vestibular migraine and vestibular non-PPPD, we can look at this non-PPPD patients look closer to the healthy volunteers, and PPPD shows a very disorganized navigation. We can summarize this navigation performance in this metric called the cumulative search error, in which we have statistical differences between those groups. But these differences in this graph is in an egocentric setting. We can modify the Morris-Watermaze to look for a more egocentric setting, or we can put it in a more allocentric setting. And egocentric is the target is to my right, I am the reference point. Allocentric is that the map, the spatial cognition is the reference point. And when we focus on that kind of setting, the differences, the impairment of PPPD, it grows larger. So from this, we believe we can now say that PPPD displays a spatial navigation impairment, particularly in allocentric settings. So let's move into virtual reality. When we test virtual reality, a factor that PPPD and also vestibular migraine patients show very strongly is VR intolerance. Their visual vestibular dysfunction gives them a lot of motion sickness. And there in those graphs you can see how much of the trials, even 20% of the trials, could not be completed in those groups. But what happened? Does this VR intolerance influences navigational performance? We thought that yes, that it was motion sickness and visual vestibular dysfunction what will impair vestibular navigation, but we found the opposite, that the performance in navigation was equal, exactly the same in the non-immersive and in virtual reality. So we say that despite larger virtual reality intolerance in PPPD, this does not further affect spatial navigation. So the spatial navigation impairment, we think, would be independent of visuo-vestibular processing. Now, when we analyze gaze, and this is how it is done, this is a new heat map showing where the patients look into the screen, and healthy volunteers actually are quite focused. They look into the middle of the area and from time to time look for a visual cue. But PPPD patients are moving their gaze, their eyes all over the place, checking and rechecking and rechecking and rechecking for those visual cues. When we look into the other control groups, again, they're a little bit more similar than healthy volunteers. Perhaps vestibular migraine patients also have a more dispersed gaze behavior. And when we check for this in the non-immersive and virtual reality, we actually got basically the same graph. So again, when faced with a spatial navigation challenge independent of if head movements are available or not, PPPD patients seek more visual cues, far more than the controls. They try to compensate. We believe they try to compensate their impairment with visual cues. Finally, when we analyze head kinematics, well, every single patient with a vestibular pathology and in the same level move their head a lot less than healthy volunteers. And this appears not to depend on the diagnosis, but if there is any kind of vestibular damage. So we believe that all patients with some kind of vestibular disorder show less head movements while exploring a virtual reality setting. Putting all this together, we believe that in PPPD, it's a core feature that there is an impairment in spatial navigation, in an allocentric spatial navigation. We believe that this navigational impairment appears to be independent of visuo-vestibular dysfunction. And furthermore, we think that PPPD patients appear to seek compensation of this impairment through increased visual cues exploration through gaze. And in terms of head kinematics, this appears not to depend on the nature of the presence of PPPD, but rather on vestibular peripheral dysfunction. So this is what we have found. I hope this helps us all understand a little bit more of this fascinating theme of functional dizziness and persistent perceptual postural dizziness. Thank you very much.